First of all, good morning. Today I'm going to discuss about the class 12 organic chemistry related to the haloalkane, and then the introduction of the haloalkane is most important, and I'm going to discuss about the introduction of the haloalkane. Then what is the introduction? What is the what is the introduction of the haloalkane? The organic compound is derived from the aromatic hydrocarbon by the replacement of the one or more hydrogen atoms with the halogen atoms. Like halogen atom means fluorine, chlorine, bromine, or iodine. That is called haloarene. And in this compound, halogen atom act as a functional group that are bonded to a carbon atom over at least one hydrogen when hydrogen at least on the benzene ring by the covalent bond. This compound don't ionize in ionized aqueous solution, and to give the halide ions. Halogen are represent as AR halogen, where the AR means aromatic ring, and halogen means fluorine, chlorine, bromine, and iodine, and and AR means aryl halide, or the halogen means fluorine, bromine, and iodine, and aryl halide aryl halide means the another name of the aryl halide is haloarene, and the derivatives of the arenes in which the hydrogen atoms of the benzene rings or the side chain is replaced by halogen atoms are called the aromatic halogen compound, and haloids are used in the preparations of the pesticides, like pesticides means like DDT, IBSC, fungicides, aniline, and phenols, etc. And then now I'm going to name at least the specific examples of the haloarenes and arenes, and then the one or more hydrogen replacement by the halogen atom, that is called the haloarenes. And now I'm going to write down on my copy, and the organic compound organic compound organic compounds are derived from the aromatic hydrocarbons by aromatic hydrocarbons aromatic hydrocarbons by the replacement of or the one or more hydrogen atoms atoms with the halogen atom with the halogen atoms. Halogen atom means chlorine, chlorine, bromine, or iodine. That is called haloarenes. That's called haloarene. That's called the haloarene. Now I'm sorry. The name of the topic is haloarene. Haloarenes topics. The name of the chapter is haloarene, and I'm going to discuss about the haloarenes, and chlorine, fluorine, bromine, iodine. That is called haloarene. That is called haloarenes. Uh, uh, and this is it is represented in this compound. This compound does not ionize in the aqueous solution. The compound the compounds don't ionize in aqueous solution to give halide ions to give halide ions, and the haloarene Haloarenes are represented represented as then connected with halogen atom, and where AR means aromatic ring. AR means aromatic ring, and halogen means in the halogen means fluorine, chlorine, bromine, or iodine, and that is called haloarene. And then the next I'm going to describe about structure of the haloarenes. And the structure of the haloarenes is the figure. We can see that figure. And the name of this compound is arene. And then the halogen atom is the hydrogen atom. One or more hydrogen atom is replaced by the halogen atom. Then is the name of the product is the name of the compound is halogen, and then the name of this compound is haloarene. And then I'm going to describe about next I'm going to describe about the classification of the haloarenes. It is most important. And then classifications of the haloarene. Point number two, classification of the haloarene. Classification of the haloarenes. And there are of the two types. Then classification of the haloarenes is there are two types. And then first of all, one oral halide in which the halogen is bonded directly to the carbon of the benzene ring. For example, chlorobenzene. And B or alkyl halide or the side chain halide in which the halogen is bonded to the carbon of the side chain attached to the benzene ring. And benzyl chloride is not a haloarene, or as the chlorine atom is not directly bonded to the carbon atom of the benzene ring. For example, like chlorobenzene or benzyl chloride. Oral halide in which the halogen is bonded directly to the carbon of the benzene ring. Direct carbon of the benzene ring. Carbon of the benzene ring. And then the specific example of the aryl halide chlorobenzene. An example, for example, chlorobenzene. And then another classification of the haloarenes. Haloarenes are the alkyl halide, oral halide. Oral alkyl halide, halide or the side chain halide in which the halogen is bonded to the carbon of the side chain. And then we can clear that the halogen atom is bonded to the carbon of the side chain attached to the benzene ring. On the side and the halide or side chain halide in which halogen is bonded to the carbon of the side chain attached to the benzene ring. And then these classifications of the specific example of the disclassifications, and chlorobenzene and benzyl chloride. benzyl chloride, and then we can see that from this structure, and the compound, or the name of the compound is chlorovenzene. It is alkyl halide in which halogen atom is bonded directly, and then the name of this compound is chlorovenzene. The chlorovenzene, and the another types of the another classification of the haloalkane. Then we can see that we can see clear that we can see clear that oral alkyl halide, or the side chain or halide in which halogen is bonded to the carbon of the side chain attached to the benzene ring. And then the structure of the name of the structure is CH2Cl, and the name of the compound is benzyl chloride. Benzyl chloride benzyl chloride. And we can see that from this figure, the chlorine is side chain of the benzene ring, and that is called oral alkyl halide, or the side chain halide, in which halogen is bonded to the carbon of the side chain attached to the benzene ring. And then next I'm going to discuss about nomenclature. Nomenclature is most important, and the many types of the compound is specific naming, and then the naming of the haloarenes is given below. And then the nomenclature. Next I'm going to discuss about the nomenclature. Nomenclature. Point number one. That if oral halide have a halogen atom directly bonded to the aromatic ring according to the IUPAC system. IUPAC system is most important, and the IUPAC, according to the IUPAC systems, they are named as a halo plus haloarene, and then it is most important. Have a halogen atom directly bonded to an aromatic ring, and with according to the IUPAC system, according to the IUPAC systems, according to the IUPAC system, then they are named as halopolus arene. That is then the equals then the haloarene. Halopolus haloarene. Then the according to the IUPAC systems, and then specific compound. Then for example, the name of this compound is halobenzene, and another structure. The name of this compound is chlorovenzene, and then next, this compound is the name of this compound is iodobenzene. And next, number V. If the more than the one same halogen atom are divisions, their positions on the ring are indicated by the members using a lowest sum rules or the appropriate prefix. Then the appropriate prefix means ortho, meta, para, fluoride, dry, tetra, penta, etc. Then the parent compound, and the structure. The Cl and more than the same halogen. Then the more than same halogen atoms are the fusions. Their position on the ring. Their position on the ring are indicated by numbers. Numbers are using the lowest sum. Lowest sum rules or the appropriate prefix ortho, meta, para, followed by the di, tri, tetra, penta, etc. Then the parent compound. The name of the compound compound is orthodichlorobenzene, and the name of this compound is orthodichlorobenzene. Orthodichlorobenzene, and another compound is, the name of this compound is chloro, and there are three chlorine, and the name of this compound is 1,3,5 trichlorobenzene. And then and the next another naming, and point number C. Point number C. If one of the group of the functions on the ring gives the special name to the molecules, then the haloarene. Haloarene is a name as a halo derivative of the special name. The carbon atom attached to the such as a group is given number 1. Then the it is it is most important naming, and it is if the one of the group. And listen carefully. Then we can see that if one of the groups present on the rings gives the special name to the molecules, then the haloarene is named as a halo derivative of the special name. The carbon atom attached to the such as group is given number 1. And then the the name of the compound is 3-chlorotoluene, or another name of this compound is metachlorotoluene. 3-chlorotoluene, and another name of this compound is metachlorotoluene. And another structure is, and then the name of this compound is 4-chlorotoluene. And another name of this compound is para-chlorotoluene. And another structure BrCl. The name of this compound is 2-bromochlorobenzene. And another compound, name of this compound is 2-chlorophenol. The name of this compound is it is we can see that the name of the compound is 2-chlorophenol. And the point number D, another point at last point, the D number. If the same group are different, if the group are different, and none of them gives a special name to the molecules, the positions of the groups having the highest priority gets number 1. The substituents are named in the alphabetical order, and the priority some groups follows the order. And I think that this compound is naming from the alphabetical order. Point number D. Point number at first of priority priority order from this compound. COOH is first priority, and then SO3 years, then CSO, then O years, and then NS2, then halogen, then NO2, and then R, etc. Then this is called the alphabetical order, or the priority order. Some groups follow the order, and the substitutions are named in the alphabetical order, and the priority of the some groups are follows the order. And then for example, this this priority order, according to this priority order, for example, some of the for examples. And the name of this compound is listen carefully. Listen carefully. We can see that we can clear that. We can see this compound is 2-chloro. 2-chloro. According to the priority order is according to the priority order is halogen is first. Halogen is first. So that 2-chloro, 2-chloro 4-nitro, then the 4-nitro. 4 nitrophenols, then the OH means phenol, and we can see that. And another compound, the CS3. The name of this compound is it is we can see that we can listen carefully. And then the name of this compound is according to the alphabetical order. Bromine is first, so that CS3 bromine is the first, then the CS3, then so that the name of this compound is 2,4,6 trimethyl. The CS3 means methyl group, methyl, and the name of the CS3 is methyl, so that methyl, we can write down the methyl. And bromo, trimethyl bromobenzene, 2,4,6 trimethyl bromobenzene. Name of this compound is 2,4,6 trimethyl bromobenzene. And another compound is we can see that, listen carefully, and we can see that C2H5, and then the Yano 2, and the F. Then the according to the alphabetical order, for ethyl, 1-fluoro, 2 nitrobenzene. Then we can finish that nomenclature. And then another describe about the general method of the preparation of the haloarene. It is most important, so that general method of the preparation of the haloarenes. And at first of all, from the halogenations, it means a nuclear, it means electrophilic substitution reaction. And the halogenations means another name of the halogenation is electrophilic substitution. And then I'm going to describe about the general method of the preparation of the haloarene. We can write down. I'm going to write down my copy. Then the general method of the preparation of the haloarene. Preparation of the haloarenes. It is most important. I think that it is most important for the class 12 or for NAB exams. So that at first of all, point number A, from the halogenation, and then another name of the halogenation is electrophilic substitution reactions. Point number A from the halogenation. From the halogenation, then it is means halogenation means electrophilic substitution reaction. Electrophilic substitution, and it is I'm going to describe about detail. I'm going to describe about from the halogenations. It means haloarene. Haloarene can be prepared from the benzene by the direct halogenation in presence of the halogen carrier. halogen carrier or chlorobenzene is prepared from the benzene by the direct chlorination in presence of the halogen carrier ions, iron or FeCl3 or the anhydrous AlCl3 as a catalyst at the room temperature. It is an electrophilic substitution reaction, and this Lewis acid act as a catalyst, and its function is to carry halogen to the aromatic hydrocarbon, so called halogen carrier. And then the structure of the halogenations, electrophilic substitution. We are going to do the reactions. The name of this compound is benzene. The name of this compound is benzene. Benzene is treated with Cl2 chlorine, and then in presence of the FeCl3 at the room temperature or the dark and then to give the product Cl. Then the name of this compound is chlorobenzene. The name of this compound is chlorobenzene. The name of this compound is chlorobenzene, and the side product is hydrochloric. And the bromobenzene can be prepared in the similar ways, using the Br in presence of the FeBr3. The name of this compound is benzene. We know that already. Benzene. The name of this compound is benzene, and benzene is reacted with bromine. Bromine in presence of the FeBr3 at room temperature, and then to give the product is the name of this compound is bromobenzene. And the side product is hydrogen bromide. And since iodination of the benzene is a reversible reaction, iodobenzene is we know that we can see clear here. Iodination of the benzene is a reversible reactions. Iodination is carried out in presence of the oxidant like SNO2, SNO3, SiO3, etc., which drives the reactions in the forward directions by oxidizing the HI into the I2, so that we can directly listen the reaction. And the name of this compound is benzene. Benzene is reacted with iodine. Then it is a reversible reaction. So that the name of this compound is iodobenzene. And then the side product is hydrogen iodide. Hydrogen iodide. So that the hydrogen iodide. And how to prepare iodine from the iodic acid. Then I'm going to describe over this detail. According to the HI is treated with the SiO3. Then to give the I2 plus side product is H2O. The balance is the reactions, the 3 iodine, 5 hydrogen iodide. The name of this compound is iodic acid. The name of this compound iodic acid. So that fluorobenzene cannot be prepared by the direct fluorination, as the reaction is violent. The reaction is violent and uncontrolled. Then the point number B, the industrially. Then the another preparation method is industrially. Point number B, industrially. Industrially, and then the industrially means chlorobenzene is prepared by the passing the mixture of the benzene vapors, and benzene vapors, hydrogen chloride, and the oxygen over the cupric chloride as a catalyst at about 220 degrees Celsius to 230 degrees Celsius. Then the name of this compound is rusting process. It is most important. And the reactions I'm going to write down the reaction on my copy. The name of this compound is benzene. the name of this compound is benzene. React with the hydrogen chloride hydrogen chloride and mixture of the benzene vapor or the hydrogen chloride over and oxygen over the cupric chloride. Oxygen 1/2, oxygen is half, and then the cupric infusion of the cupric chloride. Then the at the temperature 220 degrees Celsius to 230 degrees Celsius. Then to give the new product. The name of this compound is chlorobenzene. And the side product is water, just water. Then the another preparation method of the haloarene, point number C, from the benzene diazonium salt. It's most important. Point number C. From the benzene diazonium salt. Benzene diazonium salt. And the diazonium salt is obtained by treating and the aromatic primary amine with the nitrous acid. Nitrous acid means NaNO2 plus NaNO2 plus HCl below the 5 degrees Celsius. So below the 5 degrees Celsius, and it is like a cool condition. And this reaction is called diazotization reaction. So diazonium salts are very important synthetic reagent in the preparation of the wide variety of the valuable organic compound. We can clear that diazonium salt are very important. Diazonium salt is a very important synthetic reagent in the preparation of the wide variety of the valuable organic compound. So that the reaction of the benzene diazonium salt is the aniline. The name of this compound is aniline. Aniline is treated with SNO2 plus HCl. Infusion of the temperature is like 0 degrees Celsius to 5 degrees Celsius. It is most cold condition, so that they to give the product is NaCl. The name of this compound is benzene diazonium chloride. It is most important. The name of this compound is benzene diazonium chloride. Benzene diazonium chloride, and the side product is water. Then the side product is the name of this side product is water. And the chlorination, chlorarene and bromoarenes are prepared by the warm of freshly prepared diazonium salt solutions with a cupric chloride or the cuprous bromide dissolved in the corresponding halogen acid. This reaction is called the Sandmeier's reaction. This reaction was proposed by the Swiss chemist Robert Sandmeier in 1884. And then the another reactions is the name of this compound, benzene diazonium chloride. We are already know. Benzene diazonium chloride. The name of this compound is benzene diazonium chloride, and reacted with infusion of the freshly warm infusion of the cuprous chloride for acidic medium, and then to give the product is Cl. The name of this then the side product is nitrogen. The name of this compound is chlorobenzene. The name of this compound is chlorobenzene. And another reactions is N2 NaCl. The name of this compound is benzene diazonium reaction. Benzene diazonium chloride. And treated with a freshly warm infusion of the cuprous bromide. Cuprous bromide means Cu2Br2. Infusion of the hydrogen bromide. And then to give the new product is the name of this compound is bromobenzene. bromobenzene, and side product is nitrogen. Nitrogen. If the benzene diazoxide is warm with the copper powder in presence of the corresponding to halogen acid means hydrogen chloride or hydrogen bromide in place of the cuprous halide, so that cuprous chloride, CO2 Cl2 or the CO2 Br2 haloarenes obtained. This modification reaction over the Sandmeyer reaction, it is called the Gattermann's reaction. Then this reaction is modified. This modified reactions over the Sandmeyer reaction is called the Gattermann's reaction. And then the another compound is then the another reactions we can write down the another reaction. And the name of this compound is benzene diazoxide chloride. Benzene diazoxide chloride. Name of this compound is benzene diazoxide chloride, and cupric chloride, copper for acidic medium, warm, freshly warm. The benzene diazoxide chloride is treated with Cu for HCl. Then to keep the freshly warm, then to give the product is the name of this compound is chlorobenzene. The name of this compound is chlorobenzene, and the side product is nitrogen. And another reactions is in presence of the CuHBr. The warm, freshly warm, and then to keep the product is Br. The name of this compound is bromobenzene. And side product is nitrogen. Iodobenzene is obtained by the warming the diazoxide salt with aqueous potassium iodide solution, and then aqueous potassium iodide solution, and the name of this compound is benzene diazoxide chloride, and this Cl means benzene diazoxide chloride. Benzene diazoxide chloride reacted with the aqueous potassium iodide in warm, then to keep the product is iodobenzene, and the side product is nitrogen plus potassium chloride. It's most important. Then the fluorobenzene is obtained by the reactions of the benzene diazoxide salt with the fluoroboric acid. It is most important fluoroboric acid to give the to produce the diazonium fluoroborate, which on the heating the produce fluorobenzene, which on heating produce then to give the fluorobenzene. And from the we can calculate that from the reactions. The name of this compound is benzene diazoxide chloride. The name of this compound is benzene diazoxide chloride, and reacted with fluoroboric acid. The name of this compound is SbF4 means the name of this compound is fluoroboric acid. Fluoroboric acid. Benzene diazoxide chloride is reacted with fluoroboric acid. Then to give the new product is the name of the product is NBF4. The name of this compound is benzene diazonium fluoroborate, and then the on which on heating produce then to give the product is the name of this compound is fluorobenzene, and the side product is BF3 plus N2. Then this reaction is called Wells schemes reactions. Then this reaction, the name of this reaction is Wells schemes reactions. And so next I'm going to another describe about the properties of the haloarenes. It is most important, and there are two types of properties. There are two types of the haloarenes, and first of all, physical property, and then the chemical properties. Physical property is most important, and then the most important is the chemical property, so that we can we can study that another part, so that now now I'm going to closing my pen today, so that today I'm going to today I'm going to closing my pen, so that tomorrow next day I'm going to describe about the property of the I will describe about the properties of the halogen next, so that now I'm going to closing my pen, so that it is it is most important physical property and chemical property, so that then the chemical property is most important.